So today, Alessandro Iannacci speaking. We will discuss about Zedge. What is Zedge, why it is useful, and how it works. In Techedge, we are always worried about the quality of our Zedge code. So, how to improve it? There are many tools that allows us to have different indicators that indicate us the quality of the code, such as the number of the objects in the custom developments, the line of codes, the complexity, the alerts, and so on. Information, standard tools, can be divided in two big categories. One are the metrics, such as line of code, number of objects, line of comments, and the other category is the violations, that are basically the errors that we have in our custom code. So, what do we need to create an engine to scan our code and to verify the quality? First of all, we need a scan engine. We need an integration of the scan engine with the lifecycle management. And we need a dashboard to display these information in a human repeatable way. With Zedge, like a slot machine, we have selected this combination. Engine, we have selected the code inspector that is available from standard. We will see well later. For the integration in the lifecycle management, we have selected ABAP Test Cockpit. UI. One is the ABAP to XLSX reporting. ABAP to XLSX, I want to remember you that is a project made by our colleague Ivan Femia, that is in Chicago now, handled from GitHub. And the other way is an ELB in the subQuery. This is how Zedge is placed between the other vendors' products. Here we have Virtual Forge that is using an external engine instead of the code inspector. In the lifecycle management is using ABAP Test Cockpit like us. And for the analysis is using the subGUI and subBW. In detail, how our scan engine works, the code inspector. The code inspector, first of all, what is it? It's a tool for checking the static ABAP coding. You can scan with the code inspector all the object repositories, top performance, security, reliability, and statistical information. This is the transaction SCI to create a variant and object set for the code inspector. Is the list of the checks that you want to perform on the object set. You can select which kind of check you want to do under the aspect of security, syntax check, maintainability, and so on. There is a set of objects that it's like a filter, basically, that allows you to check a package or all the Z development in a system, for example, restrict this selection. The code inspector is integrated in the most used transaction for developments like SC58, SC57, Bench, SC80, and from the slide you can see how to run it directly on the object that you have selected. And here, you cannot run it on a group of objects, but you can run it only on the selected object. So if you want to run the code inspector on multiple objects, you have to use the object set that we saw before. This is the result list of the code inspector that is giving you the problems that has been found in the code under three aspects. the priority 1 that are the errors, priority 2 that are the warnings, and priority 3 that are the informations. ABAP Test Cockpit is like an extension to the code inspector that integrated in the lifecycle management. ABAP Test Cockpit, you have a different customization page, that is transaction ATC. From here you can schedule running, for example in the night you can decide to scan some particular packages and the next morning you can review it. Or from here you can also apply for exemptions. That means that you can say to the system that this error is not an error in real, it's a false error. From this cockpit configuration, you can also reach the page of the code inspector configuration to create the variant and the object set. This is the main the main advantage that we have with the ABAP Test Cockpit, that we will call ATC for now. First of all, you can execute it on directly from the SE80 or SE58 and so on. So you can select the object just by dragging and drop the object inside the ABAP Test Cockpit console. So working on the new development tools for Eclipse. Here you have an example where we have selected a package, right? Check with that ABAP Test Cockpit with the transaction that we will decide. And as you can see, all the objects that are inside the package has been selected. And choose which code inspector variant you want to use. The powerful thing is that all the results from the ATC are not in a row list like with the code inspector, but are presented in this way that you see on the slide. So here you have one line for each error that the ATC have found with the and if you click on it, you have the details, and double clicking you reach directly the line of code that is creating the problem. You can also apply for exemption directly from here. You can ask to your quality manager, for example, that this should not be considered as an error. In addition to our scan engine and the integration to the lifecycle management, Techedge has developed this add-on for the code inspector, that is .Zedge HardCode. What is .Zedge HardCode? It is an add-on to the code inspector that allows the code inspector to scan also for static strings that are inside the code that should be replaced with, for example, a customizing table. Let me show you an example. For example, in this slide, we have a program where we have an if condition with a lot of hard-coded values for the company codes. In case in future there will be the need to change one of these company codes, it will be a mess, because who will change it? You have to request a change request, then you have to move it with the charm. So it is better to avoid this kind of situation and to use, for example, a customizing table. And this is why we have created the HardCode add-on. So basically now we have everything. We have the scan engine with the business HardCode finder. Then we have the ATC as integration with the lifecycle management. If we add the ABAP to Excel SAX to create a dashboard, we have our Zedge. Basically, what is it? It's a product that enhances the ABAP Test Cockpit, presenting the results in a beautiful and simple Microsoft Excel report. Designed for different personas, we will see it later. And in addition, each check of the code inspector are binded with 5 indexes that .Zedge is in the report. These indexes are quality, maintainability, performance, security, and analytics. In addition to these indexes, there are also two indicators that are maintainability index and cyclomatic complexity that we will see later. This is how the report will look like. So it's like an energy indicator that you have for the house, for example. Here you have the 5 indexes that I was speaking about before. Here you have the global score that is reported here with the energy indicator. In addition to the global indicators, you have the same indicators split by objects that you have in the package that you have scanned, for example. This report, that is the one used for generating the Microsoft Excel, can be changed for different persona. For example, developer needs an aggregation by method. The team leader does not need an integration by method, but for him is enough to have an aggregation for object, for example. And finally, for the quality manager or for the system owner, to have an aggregation for package. So this is another index, in addition to the 5 indexes that I told you before. That is the maintainability index. It's available in the Excel file, and the maintainability index is not used now to calculate the global score, but it's very important to understand if a method or an object is maintainable, and should always be kept high, because the higher it is, the better it will be maintainable. The other index that is included by Dr. Zedge is the cyclomatic complexity. Cyclomatic complexity measures the complexity of the method or of the object. This one also should be kept low, because the more is high and the more the program is complex. And so the maintainability is less. So with these informations, I want to show directly on the system how the Dr. Zedge works. So here we have our test system. We have a package with a lot of objects, if you see here under the classes. Many. So if I right click here and I select check with ABAP Test Cockpit, as you can see, the ABAP Test Cockpit has selected all the objects that are inside the package. That are 4,189 options. I have the ability to select which variant I want to use. For the Dr. Zedge, we have 2 variants. One is for the violations, and one is for the findings. These variants can be created manually with the help of the configuration guide for Dr. Zedge that we have internally in our Athena. The first thing to do is to run it with the findings, with the metrics variant. The metrics variant extracts for all the objects that we have selected all the information regarding the line of codes, the number of comments, and this kind of information. Okay, these information are not human readable. Okay, so for now we will not take care of them. We will see it directly in the Excel. The other step is to run the ATC with the violation variant. Violation is the variant that allows us to know which problems are inside our custom developments. Under these 5 indicators that I told you: quality, maintainability, performance, security, and analytics. Here you can see all the errors that has been found. If you double click, you will see the details here. you can apply for exemption, and you can also navigate directly in the line of the code. To generate the dashboard for the Zedge, I open the IC38 and I run this report that is the one coming by standard with Zedge. So for the metrics, I have to select the last metric run that I just performed now. And for the evaluation, I have to select the other one. Then I can choose which role I want to use. In this case, team leader means that we will have a grouping by object. And then I want to get it via email. So I will write my email address here and I run the report. Okay, now after some time, I should have our .zedge here. Okay, .zedge scanning result. Let me download the attachment. Okay, here we have our report. So we have the property page where you can see which are the run that we are using for this reporting. You can see which is the system, the version, which is the license of the .zedge, and which is the client. If you go in score, that is the main page, you will see the summary of what happened during the scanning. So here you can see that the global result is A+++, that is the best. And you can see also regarding the 5 indexes, quality, maintainability, security, performance, and readiness, which are the points that we got. If you go on the report summary, you have the same information, but with some more detail. For example, for the metrics, you have also the number of objects, the line of the codes, the maintainability index that I was telling you before, that should be always high, and the cyclomatic complexity that should be low. And for this one, you have to see the average value. Quality, you have the findings. For maintainability, you have the findings and the line of comments that are taken in consideration both to create the maintainability index. For security, you have the findings, performance, you have the findings, and ANA, you have the findings. So, what does it mean? That for quality, for example, if quality is based on findings only, if you have a lot of findings, this score will decrease. If you have, for example, a lot of findings and the line of comments are under a certain threshold or they are too much, also in this case, the maintainability indicator will decrease. And in addition to these 5 indicators, we have also the maintainability index and the cyclomatic complexity. The report detail shows you for each object in this case because we have selected the team leader. For each object here you can see this information. So you can see the 5 indicators, 1, 2, 3, 4, 5. Then you have step volume and the decision density that are used to calculate the cyclomatic and the maintainability index. These 2 indicators, as I told you, are not used for the global score, but they are very important because if you have an high cyclomatic, means that this code is not so good for maintainability. And it is better, for example, to split 1,000 line of codes into different modules. For the maintainability index, same. If you have a high maintainability index, it's okay. But if you have a low maintainability index, means that something is wrong in your code. That probably you are not using the right line of comments. You are not. Your code is too big and there are no subroutines, split it, and so on. I have also some other information about generic information about the particular object. For example, the number of comments, the line of codes, who is the last person that has changed it, the description, the name of the object, and the type. So for now, to conclude, I want to show you some example on what not to do. For example, for the quality indicator is checked by the HardCode add-on. So try to avoid these kind of things and try to use instead a custom table. Okay. Maintainability index is low if you use too less or too many comments. So here we have an example. It's a part of the code without comments completely. It's unreadable. And this, of course, have a low maintainability index, and will also have a low maintainability indicator. I mean the maintainability index that is calculated in the detail. The right one should be like this. So at least 2-3 comments for each 50 lines. High cyclomatic complexity, that is also involved in the maintainability. As you can see here, you have a lot of if and case that are making this code complex with a lot of paths, and it's complicated to maintain. If you split it in different methods, for example, local methods, it will be more readable and easier to maintain. In this case, the cyclomatic complexity indicator will decrease.
Thanks. Bene, bene.